And in my mind, I said I was going to stop it and restart it just before starting. I completely forgot. All right. So f of x plus h, remember, that's just f of 2. Okay, so f of 2 is just plugging into that original function, negative 2 times 2 squared plus 4 times 2 plus 4. Okay, so that equals 2 times 2 is 4, times 2 is negative 8. Well, negative 2 is negative 8. 4 times 2 is 8, plus 4. These two cancel each other out, so you end up with 4. So we know that f of 2 equals 4. Yes?
How do we find out that, like f of x plus h,
Mhm.
how do we find out that it was f of 2?
Oh, because that's your initial point.
Initial
That's
point,
just,
which
yep,
is
that's
0.
going to be your x. And then your x plus h is just your x value plus
The distance.
the distance.
Okay.
So all we did was just calculate the distance.
Right, okay.
Yes.
And so how you're determining the x versus x plus h is whichever one comes first on the number line?
Exactly. Yep.
So if it was 2 and 4, then
Mhm.
2 would be the x,
Mhm.
and 4 would be
The x plus h.
x plus h.
Yep.
No matter what order they write it in.
Yep, it's always just from left to right. All right. So to find our f of x, we know our x is equal to 0, so that's just f of 0. Okay, so f of 0 is just negative 2 times 0 squared plus 4 times 0 plus 4, which those just disappear, so we end up with 4. So f of 0 is equal to 4. Okay. So we have our h, we have our f of 2, and we have our f of 0. So we have our everything we need to find the slope. Okay, so you know the secant slope of the secant line is f of x plus h minus f of x all over h, which is equal to your f of x plus h is f of 2 minus your f of x, which is f of 0, all over your h, which is 2. Yep, so you'd actually end up with 0. So you have f of 2 is 4, minus f of 0 is 4, over 2, so it equals 0. Okay. So the thing is, the slope of the secant line and regular slopes have the exact same meaning. If you have a positive slope, it's going to be a positive number. Negative secant slope is negative, and when the slope is equal to 0, it's just a straight line.
Do you ever have it where h equal to 0 and it's undefined, that the slope is undefined?
Yep, it is. It's kind of a point if you have a graph. If let's say you have this graph here and it goes vertical, then when you have that vertical slope, that's when it's undefined. Kind of like how x equals 4 is undefined simply because it fails the vertical line test.
Right.
Yep, it would be the same thing here. Oop. All right, any other questions on this one? All right. Okay, now this one's actually just a little bit different, so I'm going to go through this one kind of quick because in case you run across it, I want to make sure you know how to approach it. So let's say you want to find the average rate of change. of f of x equals 3x squared plus 3x minus 1 from x equals 2 to x equals t. Okay. That was just a little bit different because it just goes from 2 to some unknown value of t. Okay, so we start off the same way. We have our 2, and we're going to t. Okay, so we know that 2 is your x, and t is your x plus h.
Question.
Mm-hmm.
How do you know that it's the second one because couldn't it be a number lower than 2?
Nope, because when you have x plus h, then it would be x minus h if it was lower. So whenever it's x plus h, it's always going to the right. Does that make sense?
No, it does. I'm just saying because t can be technically any value, so that's why I'm playing devil's advocate. If it's on the other side, then
Well, if you kind of think
we're
about,
replacing x plus h, so x plus h, so that's why.
if you kind of think about slopes, like just on a regular linear, it's always either up to the right, down to the right. So it's kind of this, it's always this to the right direction for slopes. So we're kind of,
Yeah.
I guess that's kind of the best way to think about it.
Okay.
That's why it always goes to the right.
Okay.
All right, so if you have, where did I leave I? So the first thing you want to do, notice that x is equal to 2. So if you have x plus h equals t, it becomes t equals 2 plus h. Okay. So if t equals 2 plus h, then that means that h is equal to t minus 2. Okay, so we solve for our h. So now we have to solve for f of x plus h and f of x. Okay, your x plus h is t. So it's just f of t, which just becomes 3t squared plus 3t minus 1. Okay, and your f of x, your x is equal to 2, so that's just f of 2, which is equal to 3 times 2 squared plus 3 times 2 minus 1. Okay, 3 times 2 is 4, so you have 12 plus 6 minus 1. So f of 2 is equal to 17. Oh, forgot to block that off. Oops. All right, so now we have everything we need to find the slope of the secant line, or average rate of change. So you have f of x plus h minus f of x all over h. Okay, so we know f of x plus h is just f of t minus f of x, which is f of 2, all over h, which is t minus 2. Okay, so that means we will end up with f of t, which is 3t squared plus 3t minus 1, minus f of 2, which is 17, all over t minus 2, Now, if you combine those two, you'll end up with 3t squared plus 3t minus 18.
Then you can factor that out, right?
Yep, then you can factor that one. Because this actually factors,
3t plus 9.
yep, 3t plus 9 times t minus 2. Oops, sorry, bring that up some. Okay, so you end up with 3t plus 9 times t minus 2 all over t minus 2, where those two just cancel each other out. So you end up with a secant slope function of 3t plus 9. Or if you plug in random values of t, you'd get it at different spots.
So it doesn't necessarily have to be a number, it could be another.
Yep, it could be another linear, it could be a linear function. All right, so any questions on that one? All right, so I'm gonna try to squeeze this next one in real quick. Make sure everyone's done here. Yes.
So let's say we ran across one that wasn't able to be factored, would we just leave it at that step right before?
Oh, if it couldn't be factored, then it would stay at that step. Oops. But most of them in this section should be able to be factored. Oh. All right, so let's say if we have want to estimate the instantaneous rate of change for the function f of x equals 2x squared minus 3x minus 4 at x equals -2, using the average rate of change over smaller intervals. Uh-oh, clean that up a little bit. Okay. So really all that means is that when you have -2, you're just going to get closer and closer and closer and closer to -2. Kind of like limits, but we're not using limits just yet. So we know since this is continuous, the rate of change will be the same from both sides. So really all we have to do is just pick a side and get a little bit closer. Okay. Continuous, so be the same. From both sides approaching x equals -2. Okay. So what we just want it to get closer and closer. So we want our change in x, or our h value, just to get smaller and smaller. Okay, so we know here, let's say we'll go from -2 to -1. Then we'll get a little bit closer. So from interval -2 to -1.5, then we'll get a little bit closer. Let's say -2 to -1.9. And let's say from -2 to -1.99. Okay. So we're just going to apply the slope of the secant line function to each one of those. Formula rather. Okay. So to kind of keep this somewhat together and not too bunched up. Okay, so this interval will be for -2 to -1. And in this case, this will be your x, and this will be your x plus h. Okay, so we know that the slope of the secant function is f of x plus h minus f of x all over h. Or actually, for this one, instead of using h, we can just use x plus h minus x, which is still h, but we're given our x plus h and x value, we can just plug them right in. Okay, so that means the slope of the secant line is going to equal your f of x plus h is f of -1 minus your f of x, which is f of -2, all over x plus h, which is -1, minus your x, which is -2. Okay, and we know that if we work it out, f of -1 equals 1, and f of -2 would equal 10. Okay, so we end up with 1 minus 10 over 1, which is a slope of -9. Okay, so when we have a distance of, or our h value is 1, the slope is -9. Okay, so what if we try the interval from -2 to -1.5? Okay, where in this case, this is our x, and this is our x plus h. Okay, then our slope, or you can say average rate of change, is equal to f of x plus h, which is f of -1.5, minus f of x, f of -2, all over x plus h. So you have -1.5 minus -2. Okay, and it was worked out ahead of time, so f of -1.5 is actually equal to 5, and we know that f of -2 is still 10. Okay, so we end up with 5 minus 10 over 0.5. So you notice our h value got a little bit smaller because we got a little bit closer. Okay, so that ends up being -10. Okay, so our slope went from -9 to -10 once we got a little bit closer. Okay, so we can try -2 to -1.9. Okay, so in this case, this would be our x, and this is our x plus h. So our average rate of change is equal to f of -1.9 minus f of x, so it's f of -2, all over -1.9 minus -2. Okay, so f of -1.9 is actually equal to 8.92, and f of -2 is still equal to 10. Okay, so we have 8.92 minus 10 all over -1.9 plus 2, is negative, or 0.1. I don't know why I said negative. Okay, so our h value is a little bit smaller. Okay, so that's going to equal negative 10.8. Bring that up a little bit. Okay, so we have one more, and that's for negative 2 to negative 1.99. Where this is your x, this is your x plus h. Okay, so your average rate of change is equal to f of x plus h, f of negative 1.99, clean that up a little, minus f of x, all over x plus h, minus x. Okay, so we know that f of negative 1.99 is equal to 9.89. And f of negative 2 is still 10. Okay, so that's negative 9.89 minus 10. Oh, I'll put negative there. It's not negative. 9.89 minus 10 all over negative 1.99 plus 2 is negative, well, 0.01. Okay, which is equal to negative 10.98. Okay, so as you get closer and closer to negative 2, your value gets closer and closer to negative 11. So you can pretty much estimate that the instantaneous rate of change at negative 2 will be negative 11. So the instantaneous, move that up some, change can be estimated to reach negative 11. Okay, so it's kind of like the limits where you just find values a little bit closer, a little bit closer, a little bit closer. All right. Any? Yes.
Does that mean it'll always be an estimation?
It is for if you use this method, that this kind of leads up to the derivatives. So, but we'll go into that next time. All right. Any questions?